Hi, this is Reese from Research, and today we're going to do a brief introduction to the kinematic equations. The kinematic equations are used to answer questions about objects in motion. So up on the screen, you can see the four main kinematic equations. And what you need to do is get very comfortable with these equations because you will use them to answer all of your kinematic problems. Now what I want to do in this video is run through the kinematic equations to make sure that you know how to use them and you know what each variable means. Let's start with the first kinematic equation here. This one says that xf is equal to xi plus vi delta t plus 1/2 a delta t squared. xf is the final position of our object. xi is the initial position of our object. Vi is the initial velocity of the object, delta t is how long the object was in motion, and a describes the acceleration of the object. Now what I want you to notice is how similar this equation is to our uniform motion equation. Now this equation describes motion that has a constant velocity, so no acceleration. But looking at our kinematic equation, we see there's a term that includes acceleration. So what that means is you want to use these kinematic equations when your object is speeding up or slowing down, because then you have acceleration. And you would use the uniform motion equation when your object has no acceleration, so the object is not speeding up or not slowing down. Moving on to our second kinematic equation, we see that this says Vf is equal to Vi plus A delta t. Notice this equation does not include any position, so it doesn't have a delta x. That means you would use this equation when your question does not include any information about the object's position. Now on to our third kinematic equation. This one says that Vf squared is equal to Vi squared plus 2a delta x. This equation does not include delta t, so you would use it when the question does not provide any information about the time that the object was in motion. Now on to the fourth kinematic equation. This equation says that delta x is equal to Vi plus Vf divided by 2 times delta t. Notice this equation is missing acceleration, so you would use this equation when your question does not include any information about the object's acceleration. One quick note before we end. In all of these kinematic equations, I had described position in terms of x. So we had xf, xi. This describes horizontal motion. So that's motion along the x-axis. Imagine a car going forward, back, left, right. But what about vertical motion? So imagine a ball that I throw up into the air. Well, we can use all the same kinematic equations. You just have to replace the x's with y's, so your kinematic equations would look like this. And now they describe vertical motion. This has been a brief introduction to the kinematic equations. Now what I've done so you can test your knowledge is I've posted 3 introductory kinematic questions. We have an easy, medium, and hard question, and I challenge you to try all 3. And if you can make it all the way to the hard question and answer that correctly, then you have a strong grasp of how to use the kinematic equations.